Hello and welcome to Great Things with Great Tech. This is episode 14. My name is Anthony Spiteri and this podcast is all about companies doing great things with great technology. And in this episode, it's a great pleasure to be talking to Liran Zvibel, co-founder and CEO at Weka. Welcome to the show, Liran.
Thank you, Anthony. I'm very happy to be here.
Excellent. So just before we get into Weka and everything about storage and file systems, just a reminder that if you love great things with great tech and you'd like to feature on future episodes, you can click on the link in the show notes or go to launch.gtwgt.com and register your interest. And just a reminder, all episodes are on YouTube. If you haven't subscribed yet, please subscribe for past episodes, for all future episodes to get notifications. And GTWGT is also on all the great podcast platforms as well. So Google, Apple, Spotify, go there, register and hear it in voice as well. Right, Liran, let's get into Weka. Just before we start, I've got a bit of interesting sort of research I did. So Weka, if I'm not mistaken, is like it's like a power of 10. So is it 10 to the 30 power of 10? Is that where it is?
Indeed. It's a trillion exabyte or a million yottabyte. So pretty much a gigantic number. And I don't want to say like the Bill Gates, no one will ever need the 64Ks.
Yeah.
But I'd be surprised if within my lifetime, I will end up seeing anyone actually holding a Wekabyte.
Yeah. So it's like, it's built for the future, future-proofed completely, much like what Google did, right? Google kind of did, what's Google, 10 to the 100 or something like that? So they're future-proof the internet.
Yeah. Google Plex is 10 to the 100th.
There you go.
And this is exactly why we started Weka. So when we started, we're basically thinking, hey, what kind of storage will customers need in about 10 or 15 years? Mm-hmm. Because the thing with storage companies, it takes several years to really build them. So you need to make sure that by the time you are well adopted, this is actually what the market needs. And so we went and we picked a name that played well with that idea.
Yeah, that's a good little foreshadowing there as well. That's a great example of a name with meaning and direction, I think, as well. So, I mean, you founded the company yourself with Adi Galvan in 2014. Now, you founded it in Israel, but it's based in San Francisco now, or the Bay Area, right?
Right. So I founded with two co-founders. With two other co-founders, we actually worked together at XAV that IBM acquired, Omri Palmon and Maor Ben Dayan. All of us were acquired into IBM through XAV in 2007. We remained there until 11, left, we started Weka. And yes, we have a large engineering facility in Tel Aviv, Israel, not very far away from where the original XAV offices were. And our headquarters, the go-to-market, and basically anything not engineering is here in the Bay Area.
Okay, cool. And so you've been around since 2014. You've had some pretty good rounds of funding. I did a bit of crunch basing, and you've had 5 rounds, a couple of split C-series and initial, but you've totaled about 78 million. So there's some great, investment backing in your story, but also in terms of the actual investors, the names, I was really interested to see that, you've got an investment pack like NVIDIA, Western Digital, Seagate, HPE. Do you want to just explain a little bit about, maybe the gravity as to why those guys have come and invested in Weka?
So a lot of our partners in our go-to-market are also investors, and what they're seeing, they're saying, hey, our biggest customers have big issues, and the current storage vendors cannot solve what their real problems are. We're going to market together with this little Weka company, and they actually get things solved. So by the ability to solve the real problem most customers will get in 24, 25, 26, which is going to be about a decade after we started, we are actually very good at solving the very big enterprises and corporates today. And I think when these partners see the effectiveness of the Weka solutions at some of their good customers, they all want it in. So again, we got very, very good list of some strategic investors, probably more than any other storage company.
Yeah, it's an impressive list, totally. And, I guess we haven't really talked about, what Weka actually does. What's the core of it, right? And, the tagline is, the world's fastest parallel file system, designed to solve challenges in AI, deep learning, technical computing. So it's a file system, right? That's your product, WekaFS. Do you want to just talk a little bit about that and how you came to be, doing a file system in this day and age, and a little bit of the tech behind it?
Right. So actually, the fact that we have a file system is that's what's usable. If you end up going to college and you learn how to program, and it doesn't really matter almost any programming language you're going to keep, if you pick up, you're going to write something that writes files and in directories, and you open them and you read and you write. So you need a file system. That's what's usable. And then if you look at it within the context of storage, and what we're basically doing is within the context of primary storage, there are different kind of solutions. So when customers used to need very high performance, they would go just direct attach, no shared storage.
Yeah.
And you probably remember, like, there was a very famous company, Fusion IO, a few years ago.
Fusion, used them quite a bit, yeah.
Yep. So they were just making the fastest PCIe flash cards you could ever use, and they were quite popular. But when you used Fusion, you couldn't share the data.
That's it.
But you couldn't even protect the data, so it was not really stored. So if that card died, your data was pretty much gone, which is obviously not a good thing. Then when customers needed the data to be more protected, maybe with some high availability or other features, have the ability to be backed up through a point in time, they're going and they're buying SAN or block. And these solutions used to be not as fast as direct attached, but way faster than any filer.
Trade-off there.
But the downside is the data isn't shared, because basically what you get is you would break it into many volumes, and each volume will be a target to a single initiator. So only one server can access any piece of data. Now, everything now is scale out, shared, you break it into bigger clusters, so it's not usable anymore. So customers went and say, hey, I need shared storage. They're buying a filer, like the NetApp, the Isilon, where things are easy, but performance isn't great. It's never been great. That's the reason people were buying it direct attached or block. And also, they also don't scale to where the big projects are. And when customers need to scale, they want to buy real storage, they're buying object storage.
Yes.
And this is where the namespace can scale, but now they have to go port their applications to S3. And a decade ago, it was obvious that all companies are going to finish their porting projects in 2 or 3 years, and no one will ever need a file system anymore. Fast forward to today, all of these projects actually fail, basically because the semantics, the coherency semantics of object storage are so hard to work with around shared compute and mixed compute that it's very, very hard to get. And then the world was trying, hey, storage has failed us, let's go the big data route, use a lot of very fast direct attach solution and cobble it up with some replication and see where that take us. Also, I think there was more promise in that than premise, and that didn't grow in real solution. But what we're doing with Weka is basically we create different kind of a storage system. The interface is a file system, because this is what easy for applications to run, to use. If you just want to access your data, you don't want to make any changes, you need a file system. Because this is what all the libraries assume. They assume you have a file system. So we created a file system that has almost no scalability limitations. We can have namespaces in the many, many exabytes today. maybe at some point we'll make to actually Wekabytes. But today we're limited to several exabytes, which is in practice is big enough. And on the one hand, and on the other hand, we have single client performance that is faster than the fastest direct attached or block storage that you can get. And actually with NVIDIA's new protocol, the GPU direct storage, we're showing that on their beefy DGX A100, over 8 200 gig lines, we're getting data at 162 gigabytes a second to one client.
All right,
so
that's really interesting, right? Like I see I see the vision, I see what you're trying to do, because I mean I know all too well the pain of promises of storage delivering scalability, linear scalability, and it never worked. Like I think back to my biggest pain that I ever had with storage. I'm not going to name the vendor because they're not around anymore, but I won't name them anyway because you don't want to stamp on people's graves. But they promised us linear scalability. No worries. Here's your enclosures, your disk. It was basically based on ZFS with a bit of ZIL, a bit of write cache, that sort of situation. And the back end was based on AOE protocol, right? So running over Ethernet, linear scalability there. No worries. And maybe that was the case. However, it was always limited by the front end, the header. And that's where the problem was. You couldn't scale performance at the header, which was that interface that made it that file system where you could read and write files too, right? And that was horrible. It didn't scale the linear performance, not to mention the performance issues and the latency. So I think from what I've read, WekaFS effectively bypasses all that in some architectures, because I know you guys do different architectures with the SSD or NVMe, but with the NVMe solution, you guys basically almost take over the hardware directly, don't you? And you interface with that directly. Just talk a little bit around that, because I'm finding that pretty fascinating in terms of your differentiator and how you're doing things.
Right, and this is actually spot on. So what we're able to do that no previous storage solution was able to do is basically scale metadata and scale from the client perspective. And these are two of our biggest innovations. So to begin with, we run alongside Linux, but we have our own. You can think about hardware-based hypervisor that runs alongside the Linux. So we take over a portion of the NIC, and we can share the NIC and the NVMe device, and we talk directly to the VFS layer of the kernel if it's a client. This is on the one hand, hey, just from the resource management, and then what we do, and any operation that you run would end up running through different resource on the cluster. And if you make the cluster bigger, it's going to be instantly rebalanced and mentally restructured. So when clients run a lot of their operations together, they're always running uniformly. Almost doesn't matter what kind of IOs they're actually playing, they will run uniformly across all the resources, both on data IO and metadata.
Yeah.
And scaling metadata is insanely complex. And this is what I think the biggest issue for the previous kind of solutions. Yeah. So if you had, and again, I'm not going to name names, but I think I know what solution you're talking about. But then there are the commercial solutions now. And if you have small number of large files and you're accessing them in a sequential manner, you may actually get some scalability.
Yeah, and I think that's always been the problem with files, even at a very basic level, right? The smaller the files, the more the chance for latency, and metadata is really small in terms of its makeup. So yeah, and then scaling, and I think about dedupe systems as well. The problem with dedupe systems is it's the same thing, right? Tons of little hashes, scaled massively, and dedupe systems fall over at scale because of that fact, right? You need to keep on adding like for like hardware to keep up with it effectively. So you're kind of bypassing that problem. And it's quite interesting that you guys are running, effectively your own operating system with the file system sort of thing. But you guys don't. You guys are running over it's network or Infiniband based as well, isn't it? In terms of how you do the comms between interfacing the storage to the file system. Is that correct in saying that you Infiniband or Ethernet delivered?
Yeah, definitely. So these are the two main networks that we see today. We run Ethernet, and we also run natively on AWS, and we're AWS primary storage competency partner. And obviously, there you only have Ethernet.
Yeah.
On the other hand, we're also very, very strong in AI and machine learning with a lot of GPU. And especially now when NVIDIA is the owner of Mellanox, they're pushing Infiniband extremely strong. So these are basically the two networks that make sense to support in modern data centers today.
Okay. Yeah, and we'll touch on the AWS thing a little bit later because I'm quite interested in that in terms of how you do that. But in terms of what WekaFS offers, so you still offer traditional, I guess, file service endpoints. So NFS is a block file, and you do object storage as well. Is that what you can offer from the WekaFS?
Right. So you get our POSIX interface, which is extremely high performance. So it's faster than local file system. We offer the NVIDIA protocol, the GPU direct storage, where we would read data directly from storage to the GPU memory, the HBM. And this is actually faster than the DDR speed on these servers. As I said, 160 gigabytes a second. You cannot actually read to a 2-socket memory. And then we have support for NFS and SMB. So we would run traditional other Unix-based systems like a Solaris or AIX and legacy Linux that would run with NFS, and we have great support for Windows with SMB, and then we have the Active Directory integration and also ACLs, so you can have your NTFS ACLs on the Windows part, and we would replicate them to show POSIX ACLs on the Linux part.
Okay, yep, I understand.
So these are more enterprise features that many customers are going to expect from a file-based solution.
Yeah, okay. And it's basically, to a certain, I hate using the term commodity hardware, but effectively you're right, it's software, right? So it basically runs on anything. So what's a typical OEM sort of server that you would want to actually run or be as a node in a WekaFS cluster?
And this is actually very important for us. We think that the previous model of, hey, hardware-centric storage solutions basically failed. I think you can look at Pure Storage as an example of a terrific company that we're trying to get proprietary hardware base to the market, and they're now, even while they're doing quite a lot of business, they're trading less than the original IPO day. So it's obviously very, very hard to make ends meet when you also have to go make your hardware, sell your hardware, maintain your hardware. So we're a software-only solution. It also allows us to run very well on the cloud. And we're working with Hewlett-Packard Enterprise, HP, and we're part of the complete program with Supermicro. Hitachi Vantara, which used to be HDS, actually is taking an OEM solution of Weka to market, and they call it a different name. We have customers actually running very large systems based on Dell servers, on Lenovo, on Cisco. So it doesn't matter who you like buying your servers from. You can buy a model that has a lot of NVMe devices and 1 or 2 high-speed networking. So 100 gig, 200 gig Ethernet or Infiniband. And chances are we can run on your server.
Okay, that's cool. And that again leads into that, the public cloud conversation we're having. And I know that, from what you guys kind of work on is, have that commodity hardware on premises, run a couple of servers there, do some basic modeling there. And then if you want to try and scale it up and you want to do some bigger data analytics, then you can leverage the power of the cloud. export data into S3, launch some i3 instances, and then basically use that as your WekaFS sort of cluster. So do you want to talk a little bit about how that works? It intrigues me that, and just maybe the process of when the data comes out of that on-premises situation, you export it to S3, it sits in S3, and then you fire up the i3 instances. How does the data then kind of become useful from S3 into the i3 instances?
So before that, we have another mechanism we should discuss. We call it tiering. So basically, you can have a large chunk of hot data that would sit on these NVMe servers.
Yeah.
Let's say you have a petabyte of NVMe, and then you can say, but my total data is 10 petabytes. So you don't want to store all the data on NVMe because it's expensive. Then you can have an on-prem or a cloud-based object storage for the 10 petabyte. The Weka system is going to tier the portion, the petabyte portion that you're actively working with is going to sit on NVMe, but the rest of the capacity is going to sit on the object storage. It all appears as a single file system. And I know a file can be large, and the portion that's active is going to be on NVMe, a portion that's not, it's going to be on the object storage. And then what we have snapshot capability, and a standard snapshot is like what you would expect from storage, like a NetApp snapshot. It's instantaneous to take, doesn't take away performance. It's differential in nature. But now what we can do, we can take a snapshot and push it to the object store that we're tiering to.
Okay.
At this point, when we finished pushing a snapshot, it is saved in a way that any other Weka system can attach to it and keep running from that point in time. So the original system will save another snapshot. So it's only differential. The other system only has to take the diff. But now the other system can do some work, take a snapshot, push it to the object storage, and the original system basically can show it locally as if that snapshot happened locally. And users on that system don't even know that the work happened on the cloud. And the real cool things, we can actually tier and save snapshots to two object storage systems. Okay. So you can have an on-prem object storage and a cloud object storage, and we would save snapshots to both. So if you have the on-prem system, you would run locally, so it's fast and inexpensive because the data is there.
Yeah.
But if you're running on the cloud, you're going to read from the cloud, and then reading from the cloud is inexpensive. And then when you burst to the cloud, maybe you did some DR to the cloud, the work here is done. You take a snapshot, you push it both to the S3 and the on-prem system, and now it's not a lot of work because it's only the diff. So this is a very, very effective way for our customers to have either a hybrid cloud when they're bursting work to the cloud, or a cloud DR.
Interesting.
And
yeah.
And
I think it's all about cost. It's all about cost, isn't it, really? Like, it's all about, maybe number one, there's two different cost aspects. Obviously, NVMe isn't still cheapish. It's obviously getting cheaper, but it's still not cheap. So to run petabytes of that is going to obviously cost you now. Obviously, if you're a customer that's running like a big genome sequence, or you've got the funding, you can do it. But for those different use cases, for the corporate use cases, enterprise use cases, maybe for them to buy a massive NVMe farm is going to be too expensive. So the tiering is critical to actually offload that data at a certain point, so the ongoing cost is cheap. Also, with regards to the bursting, have that server, have that system on premises, and leverage the power of that scalability in the cloud to then leverage the GPU-based systems in the cloud, so you don't have to buy them and just put them up when you want them.
Exactly.
Shut them down. So it's very smart in terms of how you've designed that to be able to make it almost seamless to get the data, crunch it somewhere, export it, put it to another location, crunch it, and bring it back. It's really impressive.
And if you run everything on the cloud, it costs a lot of money. If you just view your cloud, hey, that's what I'm using on-prem, I'm just going to run it on the cloud. Now the cloud becomes expensive. Yeah. But if you think of the cloud as your elasticity buffer, you can now plan your data and your data center in the way that the bulk of your work is run on-prem, where it's inexpensive, but you only run it 100%. DR is in the cloud, so you don't have to buy it again and not use it.
Yeah.
And when you have burst, you put it on the cloud. And then you're basically leveraging the cloud for elasticity. And you can architect your system in a way that you're leveraging 100% of your on-prem. You can increase your on-prem based on your capacity increases that are certain. And then any excess work like the weekly report, the monthly, whatever, you do on the cloud on spot instances. And if something really bad happened on-prem, you can have continuity based on the cloud.
That's great. And that's the power of software as well, isn't it? Like you were saying at the start, you were alluding to, it's not tying it specifically to a particular hardware platform and appliance. The fact that it's software gives you that mobility. It's what makes software great when you're basically basing your operation, your product on a software-driven approach. I just wanted to talk a little bit about, I talked a little bit about genoming and that sort of thing in your customer base, because obviously, you are targeting those sorts of companies that need to crunch big numbers quickly with extremely low latency. I'm thinking as well, stock exchanges, financials that need to understand their differences really quick. There's a lot of use cases there where this comes into play. In fact, just this week, our ASX, the Australian Stock Exchange, had an outage, almost a whole day outage, due to some sort of system issue. And that literally stopped everyone from trading on the day, and they were out. They didn't exactly say why, but they said there was an upgrade that was done on the weekend. I first went to storage and thought that maybe it was a storage issue, because that's typically what the issue was, just knowing about my history as well. But in terms of that, the customers that are doing the genome stuff, and I'm curious in today's world with COVID, if you are impacting that world, if you're contributing through your software, through your company, and making the world better, basically, is something happening around that? Have you got any stories?
So we have stories, and unfortunately, a lot of what our pharma customers do, we cannot reference by name.
Yes.
We have some public stories. So Genomics England is a very big customer on us, and they're doing quite a lot of COVID research, and they actually enlarged their Weka system during COVID so they can support more research to run. AMD has done quite a lot of COVID donation, and they donated several COVID research clusters. And actually, they did it with one of our partners, Penguin Computing, and the storage on these clusters are Weka. So we ended up donating quite a lot of storage there as well. So quite a lot of like Rice University and other universities are using these systems, and with the new AMD processors and Weka storage on the Penguin Computing platform. So we were very, very happy to donate there, and definitely help COVID because it's important. And what we're seeing, we are working with some pharmaceutical companies, and some of them you may or may not have heard the name in the news. And they are actually leveraging the ability to burst to the cloud and leverage tremendous amount of compute capacity on the cloud to get through the analytical phases of making sure that all the results are being viewed as quickly as possible. Because when you're running the trials, you're collecting tremendous amount of information. And it requires quite a lot of processing, and apparently the cloud is the best platform to run it. And another interesting, so genomics is one way of analytics. Another thing that many of the pharmaceutical and the research institutes are using recently is called cryo-EM, cryogenic electron microscopes. And this is basically a way for microscopes to take pictures, microscopical pictures of live tissue, live flesh. And then they can medicate a lot of the live flesh and see how does a new drug actually affect at the cellular level as time goes on.
And what I'm thinking
and
there
this is quite impressive.
No, it's cool. I like that sort of stuff. And I guess what's happening there is that there's obviously millions, potentially billions of little data points, little files. We've talked about that as being one of the drivers for the WekaFS. So you can see directly how it correlates to better performance, if you're basically processing that through that system. That's awesome. That's amazing. Well, I just wanted to ask a couple of questions just to finish off before we wrap up. So what would you say was your core innovation that basically got you started and what you built the company on? So what was the core of that in terms of the start of Weka?
So the core for us was the ability to scale I/O on many NVMe devices, both for data and metadata operations in a way that allows to extract local attached like performance to shared storage. Mm-hmm. That is one. The other one is our insistence of only using very basic services of the servers. So we could run on the cloud and we could run on any OEM vendor. And the third one is the ability to tier and save the snapshot, so we can actually provide the very advanced data services on top of the Weka. So awesome. You're not only getting fast storage, but you're getting useful storage because we manage all the life cycle around it as well.
Excellent, good stuff. And how are you going to look to continually disrupt yourselves? Like internal disruption is obviously quite big as a way to push any tech company forward. So what's your aim for internal disruption to keep you moving forward?
So one thing we're looking at is obviously adding more cloud platforms. So today we let customers burst or tier or DR into AWS. We're going to offer Azure and Google Cloud as well.
Cool.
And then you could actually save snapshots in several of them. And depending on pricing, choose, hey, today I'm bursting into AWS and tomorrow I'm bursting into Google. Yeah. And we have a Kubernetes CSI operator. So we are seeing a lot of customers switching to Kubernetes for portability.
Okay.
And they could actually choose to run what they're doing on AWS and Azure, for example, in a very, very similar manner. Obviously, they have to work hard on that. This is one. And we're adding more enterprise-grade features that will allow us to go and replace traditional SAN storage.
Okay.
And end of the day, we want to be able to go after all of the storage needs. So we want to get into a customer because their high-end storage must use Weka, but we want to have all the little, very, very long list of bells and whistles, so the rest of their infrastructure can run Weka as well. And we could tell them, hey, instead of buying 4, 5, 7, 10 different solutions, you must have us, try us for the other things, also try us for the cloud. And you're going to really simplify your infrastructure by using more of Weka.
That's cool. It almost makes me wish I was back in my infrastructure architecture days when I can go and actually, try this stuff and put it into play, because that's what I love doing. So, that's awesome. I think it's a great story. It's seriously great technology, software delivered. I love the fact that you've taken over the NVMe. You've used this awesome technology that delivers speed with software, applying it to some really great use cases, leveraging the cloud and the burstability. It's a great story. So, Liran, and just to wrap up, so we're going to put the show notes up there. You can find me at Anthony Spiteri and GTWGT podcast on gtwgt.com. We'll have the show notes up there. I'll put a lot of information about Weka. I'll put some of the Tech Field Day. You had some really great Tech Field Day sessions as well. I'm going to link to those because I think that really explains the tech in a deep way as well for all of those who kind of glad, because there was so much there. But if people want to dive deeper into it, I think those Tech Field Day videos are perfect for it. And once again, if you haven't subscribed or you're new to the show and you like what you hear, you can subscribe to us on the podcast channels or on YouTube below. And with that, thank you, Liran. Thank you, Weka, and we will see you next time.
Thank you, Anthony.
No worries.